Okay, so for somebody who is just logged in, like listening to the lecture video, we are discussing about the project. There's a difference between phase one and phase two. So phase two has the idea of a clock, where phase one was you are writing just a parser and nothing else. So now somebody said that they don't have to have actually a clock. I can just have a variable and I can keep incrementing it. So maybe I will call this as my clock. Right. So I will, so now Gitin is asking, should I set it to my clock 0.3 seconds or 0.2 seconds? Now, how will I do? How much should I set it to? So do you think this question is valid or invalid?
So since this is like my simulator, so I can take a look at maybe some real life hardware and choose something, right? I can choose to make it a balanced.
So what will you set? My clock, will you put it? Okay. Can anybody tell me? Okay. Since you brought this up, what is the unit of this, right? So anyway, physics people will keep bugging you, right? Tell me the unit of this answer. Tell me the unit. So I'm asking you, what is the unit of this answer?
Nanoseconds or something like.
Okay. Somebody is saying nanosecond. Anybody else? Any answer? Yeah, just take a guess. I mean, it's okay. I know it's been 2 weeks you are not seeing me, so you've
So
forgotten about sleep.
nanosecond seems reasonable.
Okay, nanosecond seems
The
reasonable.
actual clock cycle is in something in nanoseconds, right?
Yeah, okay,
I
let's
mean,
take
usually
nanosecond.
it's around
No, you should
nanoseconds.
tell me. I don't know, right? You should tell me. Is it in nanoseconds or milliseconds? So will you be
If
happy
you
with
use
your?
C++ and Python, then it's in milliseconds.
Okay. Any other answer? Okay. Anyway, Gitin has won the prize, but there will be second prize today. Whoever answers this, because it's been 2 weeks, so there is more love to. I mean, from my side. So let's say, what's your answer, right? What's the other unit you can think of? Hmm? Sorry. It's
Microseconds.
okay.
Frequency or something like that.
What?
Frequency.
Okay, when somebody said microsecond. Anyway, when somebody says unit, they are not asking whether it's nanosecond or microsecond, right? They're asking whether it's seconds or something else, right? In physics, you can't differentiate between the units of microsecond and nanosecond. They are just in seconds. It's just that it's just a easier way to represent nanosecond, right? Because you know that it's multiplying by 10 power minus 9. Okay, somebody said frequency. Any other answer?
Time taken for one cycle.
Sorry?
Essentially, the time taken for one cycle.
Okay, so I will tell you the answer. The answer is that there is no unit for this because this is just a variable. It's a C++ variable, right? Or C variable. So you don't have to worry about any second frequency or anything. So that's the important distinction when you're designing this second phase of the simulator. You don't have to worry about whether it is in seconds or nanoseconds or anything. You are controlling the time. You are the god here, right? It's your simulator. So it is just this. So if I tell you, let's say after I write my program for this architecture, it took 3000 cycles, right? Then I can say I can multiply whatever I want here. I can do anything using those values of the cycle, right? So here, let's say if the execution unit is 0.3 seconds, then I can just feed in that the execution stage will take 2 cycles. But the cycles itself need not have any unit because finally I am expecting an answer in the number of cycles, not in terms of seconds or nanoseconds or frequency or whatever. I can plug in any frequency I want to this simulator of yours, and I can actually simulate the entire thing. It's just that so let's say, okay, let's say I am worried about the let's say there are only two stages of the pipeline, right? Let's say only there is an instruction fetch, and the other is it's doing everything else, right? So let's say it's doing execution, write back, whatever it is. Right? Let's say there are two stages. So I will assume that this is taking one cycle, this is taking 2 cycles. Okay. Now, what will I do in my processor? Right. Let's say I'm building the simulator, right? So what will I do? I will have a main function and I will have a global variable called, I mean, you need not have it as a global variable, but let's say I have a global variable called my clock equal to 0. Okay. I have a global variable called my clock equal to 0, which means that I've just initialized it with 0. If you are a C++ geek, you will know that it will anyway be initialized to 0. But anyway, now I will, in the main function, I will call instruction fetch. Um, instruction fetch is a function. Okay. There is a function called instruction fetch. and I will do whatever I want here. It does not matter whether I take 100 minutes to execute this on the real processor or it takes 1 second to execute on the real processor. All I have to do in the last line of this statement is what? What should I write?
My
here?
clock plus 1.
Yes, my clock plus 1, right? Why? Because in my processor, the simulating, what I am simulating, I have gone ahead with 1 clock, right? And then the next instruction will be on the next function that I will call is execute.
Sir, one doubt is that like this 1 clock and 2 clock, are you deciding it or?
Yeah, I can give it as a variable, right? So I can plug it in as a value. Like I can ask the user how many, like you, let's say the user wants to simulate some processor where its execution unit takes, I mean, in the real world, maybe he has figured out that if he builds the hardware, it takes for 1 gigahertz clock, it takes 2 cycles. Then he will plug in the value 2 there. But somebody else has come up with a very intelligent design, says that for 1 gigahertz clock, his execution unit takes only 1 cycle. Then in the execute stage, all you have to change is change the variable name, right? Change the variable. So let's say now I have execute. So now I can take any amount of time on the processor. What is this processor? This is the processor that is on your laptop or in your friend's laptop if you're copying the code, right? So somebody's laptop. It doesn't matter. All you have to write is my clock plus equal to 2 because you decided that it takes 2 cycles. But if you don't want you to decide it takes 2 cycles, you can say instead of writing this, you could have written as my clock plus equal to exact time cycle. And this exact time cycle can be an input parameter to your simulator. Maybe the user who wants to use it will say that the exact time of the unit that he is trying to simulate will take 10 cycles, and maybe you'll add 10 cycles. That doesn't matter. Of course, the design becomes much more complicated, but you can still do it. So there is no unit for this my clock. It is just a variable that is taking into account how much time it takes. So that is one thing that has to go in your mind. I mean, you might think that you have understood it. You might have understood it, but generally, it's since the concept is new because you're trying to simulate something. After I explained this to your previous batch, some of them actually used Python's clock and C++'s clock. I mean, of course, they were able to get the answer, but the design becomes so complicated that they said they spent almost 1 week, all the nights working on the project. And they actually called me twice or thrice to fix their bugs because it's very difficult to fix their bugs because now you are tying your clock with the processor clock. And that itself is variable because you might be running a YouTube video or you might be running Firefox. So the simulation might not be in sync. So they were having sleep statements for everything that they assume that it will happen. But the sleep itself, it's just a process, right? So it might be, I mean, some other thing might be using up the CPU, which means that you might not get the exact time. So you don't have to worry about all those things. All you have to think about it is this is your clock. You are the god. You have designed a new universe where you are deciding how this clock moves. Maybe you have decided the clock moves for every 100 minutes in the real world, it will move 1 cycle, or for every 1 second, it will move 1 cycle. It does not matter. So you have come up with this. So there is no unit for this. I am not looking for a unit. I am just looking for the number. So instructions per clock cycle, and that clock cycle is not a definition that I'm looking for. Is this clear? Yes, go ahead.
Sir, I just wanted to ask, like, we need not actually implement the pipelining in the program, right? Like using multi-threads or something like that.
Yeah, that's what I'm saying. You don't have to. That's the beauty of it, right? So you're simulating it. You don't have to implement the pipeline. You are not designing the hardware. So that thinking shift should happen. Like if I was teaching the same class for electronics students, I would have actually asked them to build the hardware of the pipeline. Right? That's a different challenge when compared to building the simulator. In simulator, you are not actually building the pipeline. For you, the stages of the pipeline are just functions. There are 5 functions. The first function is called instruction fetch. The second function is called instruction decode register fetch. The third function is execute. The fourth function is memory. Fifth function is write back. So these are the 5 functions that you are simulating. And you are assuming that after the end of every function, you are doing my clock plus plus, which means that if it executes all these 5 instructions together, the my clock value, if it started with 0, it will be 5. If it started with 1, it will be 6. That's all that is there to it. And you are not worried what is happening here. You don't have to you don't have to launch multiple threads in parallel and simulate as if the hardware generally when we give this problem to students or anybody, I mean anybody who wants to design this, right? Generally, what will they think? They'll think that this is the one of the hardware here, so they will launch a thread here. This is some of your seniors, I think they did this. Right? They launch a thread here, so they will call it thread 0, and this thread will be handling instruction fetch. There will be one more thread which is thread 1, which will be doing instruction decode, register fetch. There will be one more thread which will be doing execute. So they will actually pass the data from this thread to this thread after this gets executed.
I was also thinking that only, sir.
Yeah, I mean generally I mean it's not you like if it given to me, I will also think like this, because I mean I'm not saying such systems are not built. Such systems are also built, but there is, I mean, it doesn't make sense if you actually think about from the big picture, because I just want to simulate.
We just have to print this clock cycle versus instruction diagram.
Yes, that's all right. So now, okay, I hope you are able to follow. If you have questions, please ask me, or else it will be difficult for you to implement the project. I'm not saying this technique will not work. This technique will definitely work, but the bugs that you will encounter, because now you're saying this thread 0 should pass on to thread 1, but when will you pass on? And there will be deadlocks. You don't even know parallel programming, right? I'll assume, of course, you might know, but I'm saying those are other challenges which you don't have to all do all this. It will be a simple program if you think about the design from the day one itself. So you don't start your editor and start writing code. Discuss among yourself what is the design for 2-3 days. Like, is this the design that I will? And you think about the optimizations in the design before you start writing a single line of code, and then you start writing the code, right? And don't overcomplicate it. So there is no extra marks for overcomplicating it, right? Nor there is a price. Okay. Are there any?
It's not even necessary that we write these 5 functions as long as the big picture output is there, right?
Yes, excellent. Yeah, you can just write everything in one function.
Okay.
Which will just make you a bad C++ programmer, but it will still work.
Okay.
Yeah, yeah, she's perfectly right, because what she's saying is, I will have a main function, I will do everything, and then I will do some part of it and do clock plus, my clock plus, and then do everything, and then do my clock plus, then do everything my clock plus. You can do it, yes, perfectly well. Okay. Are there any other questions? Okay, then I have 2 questions. One is, how many of you think that, let's say you joined Intel and they gave you a simulator. How many of you think that the simulator will be like this, or will it be like this? Will it be a simulator design A or simulator design B if you just joined Intel, or today's Apple, right? You join Apple, and of course, companies are building simulators. So do you think Apple will be using this simulator or this simulator?
Probably B only.
The answer is not straightforward, but the initial design stages will be B, and then they will transition to A. There's a language for it called System C, which will simulate this, but I mean, that's beyond the scope of your B itself, so we'll not be discussing. Maybe in architecture, we might decide to introduce you to something called System C. It's not C programming, it's called System C, where they actually design these systems, they simulate these systems. So that is the hybrid of these 2 techniques. So you can actually write a System C code which will do best of both worlds. So, but anyway, for most cases, this will suffice, because I am just evaluating the designs. The second question is, now I have 5 stages in the pipeline. Let's disagree with the way. Let's say we'll write these 5 functions because we want to be good programmers. We want to modularize our program. We'll write the 5 functions, right? So let's say I wrote the main function. Right. And I have 5 functions. One is instruction fetch is a function. Okay. This is instruction fetch is a function. Instruction decode is a function. Execute is a function. Memory is a function. And write back is a function. And each function you are calling my clock plus. Right. So I am doing my clock plus after every function. So in the main, I have some initialization. I will do all, like, reading the file, reading all the instructions. Maybe I'll read all the instructions, keep it in a buffer, whatever I do all this. And then what is the next construct that I'll write? what is the construct that I will write here?
A while loop where we will call instruction fetch.
Okay, maybe I'll write it in the. I mean, it's very difficult to write because my handwriting, I myself will not be able to read it. So. Okay. Okay, so let's say I have a variable. Okay, so now I have declared these 5 functions. It's called instruction fetch. What is the other function? Instruction decode. Exec, okay. Memory and write back. Okay, so now I have these 5 functions, and then I have okay. Let's say I do all the initializations here. Okay, so I have done all the initializations, and somebody said while loop, right?
Yes, sir.
Okay, let's put it in a while loop. So I will go on this while loop if all instructions to complete instruction 0 and I break. It means that I don't have any instruction to complete. Right? Okay. So what is the first function that you will call here?
Instruction fetch.
Okay. So let's actually look at instruction fetch. Just one function we'll look at, and we'll worry about the others later. Okay. Now, do I have to increment the clock here? So do I write my clock plus plus here, or should I not write my clock plus plus here?
So you should not write my clock plus
Excellent.
that function, because in the same clock itself 4 or 5 functions may be called.
Yes,
so
excellent, right? Yeah, great. So why Amit Bhai is saying my clock I can't write it here is because let's say I write this, right? Let's say I do my clock plus plus here, right? So let's say I did this. I did my clock plus plus. Then you are actually incrementing for the same instruction 2 clock cycles. That is fine, but there might be something else that might be doing here, right? So I don't want to do this. So where will you increment this?
So
Moment.
I don't understand where to do, like, what are the 2 places you're talking about my clock plus plus?
Here in the instruction fetch, and in the function I do my clock plus plus. In the instruction decode, I do my clock plus plus.
So you're saying we're going to do it in both of them?
Yeah, should I do it in both of them? I'm not saying it. I'm asking, like, should I do it in both of them or not? Okay, we'll write down everything, right? So maybe that will be easier. Okay, and one more thing, I'm not giving you the answer. So this is what you have to think about, and I might be telling you a lie also. So it's up to you. You have to decide whether I'm telling you the truth or not. Right? So then you have to decide, okay, this guy told me the truth, so maybe he made what he told me made sense. So for all you know, I might be telling you, I might be misleading you, just because it's fun for me. Okay. First, let's write down the design and let's see what's the problem with this design, or if there is a problem with this design. So somebody, okay, Amit Bhai said we do instruction fetch first. And instruction decode next, execute next. Next. And right, next. So how many of you think that this design is fine?
It breaks the parallelization itself. So what is the point in
Why do you think it breaks the parallelization?
like for each instruction fetch we are adding it like the
Excellent,
point of
right?
parallel.
Yeah.
In a
So for
same
each
clock cycle,
instruction,
many instructions will be there.
yeah, right. Devashi, did you understand why there's an issue with this?
No, sir.
No, what these guys are saying, I'm not saying. What these guys are saying is that if I do this, right, this while loop is going on and on for every instruction, right? Let's say to complete instruction was initially set to, let's say, 100. So let's say I want to execute 100 instructions, right? So if I have this while loop, how many cycles will this take? Like what will be if I print here, right? Let's say I printed this, right? What
Yeah,
will
so
be
you
the
have
answer?
one cycle for like an entire instruction.
No,
all
right?
5 stages.
Okay. What is the output if I print this now?
So it's not like pipelined anymore. It's like an
Yeah, it's not like pipeline, right? So
Right.
here, yeah, right. So I am doing 2 complete instructions here. So did everybody understand why? Not this, right? Like, did everybody understand why this is not a good design? Not a good design, not good design. I mean, it doesn't even work the way we want it to work. Why? Because this while loop will come. It will do an instruction fetch for instruction 1. It will do an instruction decode for instruction 1, execute for instruction 1, and do everything. For instruction 1 alone, my clock will be after the end of, so if I have this design, after the end of this while loop for one instruction, right? So this is very important for one instruction, for one assembly instruction, right? The clock cycle will be, my clock value will be 5. That is fine for the first, but from the second onwards, it should not keep adding 5 to it. This here and the answer will be 500 cycles. But actually, pipelining will not take, let's say there were no hazards, right? No stalls. Then this will not take 500 cycles. This will still take 104 cycles. So your answer should be 104 cycles, not 500 cycles. So where will you increment the clock now?
So maybe in execute, and for the first instruction we do the entire thing, and then for the rest we can just increment in execute.
Okay. So somebody is saying, okay, what you are saying is something like this.
What
right?
if we have stalls, then it won't work.
Yeah. So let's say, okay, let's go by his answer. So he's saying we'll have it here. That's what you're saying, right? Somehow and some change variation for this. So he's
Yes.
saying okay, but somebody else said some other answer. What's the problem?
He
If we
said
have
that
stalls in the pipeline,
Yeah,
then
if you have stalls in the panel, what will you do? What will you do? What will you do, by?
so
we
then
have
we
to add
can
that
have
stall.
a variable which we can set if there is a stall and then unset it after we have used.
Sir, maybe we can do it instruction fetch, because even if we have a stall, we will know.
Okay, so
We will
somebody's
eventually do instruction fetch only.
excellent. So somebody's saying we'll do it at instruction fetch. Okay, does everybody agree with it?
So what if you have an instruction fetch that does that ever happen? An instruction fetch that fails when you have to redo an instruction fetch?
Okay, when you are actually real world designing a simulator, there's something called pipeline squash that happens because of the branch prediction. Then you'll have to handle the case that you are saying. So an instruction fetch has to be reissued, but you cannot reset the clock because clock has to move
Yeah.
forward. Yeah, but let's not worry about it.
Okay, so if we don't have that, then okay.
Then okay, right? Does everybody agree with this? Okay, so I will say it's equivalent to. I will say, I mean, just to confuse you, I will say that this is equivalent to putting it here, because I have done all the 5 stages and it did my clock test. Is this okay? Or let's say I will do it here. Let's say I put it here. The moment I increment the clock. So is this okay?
This is still unpipelined, and you're doing only one clock cycle for all 5 stages.
Why do you think it's unpipelined?
Because we're not starting another instruction fetch until WB is complete.
No, right? Okay. Okay, now that's the difference. So when are you starting the first instruction fetch? At what clock cycle are you fetching the first instruction?
After the clock is incremented once.
Yes. So let's ask this question, right? For this particular design. At what my clock value am I fetching the first instruction?
In
One.
between 0 and 1 will be fetching.
Hey, there's no 0 and 1, man. This is just a variable number, right?
I mean, we'll start at 0 and it will be going on up to.
No. First instruction. The first instruction is fetched at. See, when this function is called, what is the global variable value my clock?
0.
No, not 0, man. 1, right? See, my clock plus you have done here.
Oh, yeah, after that it will be. Yeah.
Yeah, after that you are calling this function. There is no parallelism. Don't worry about parallelism. After 0, this has been incremented to 1 here. Okay. This has been incremented to 1 here. Now you are calling instruction fetch. So the first instruction was fetched when my clock value is what? 1, right?
Yes.
So
Sir, I understood why it's like pipeline now. Like
Yeah.
if there's no stalls and if it's like perfectly fine, then
Yeah. So
pipeline
yeah.
now.
At what my clock value am I fetching the second instruction?
2.
2, right?
2. Yeah, I get that.
So I actually pipeline this, right? Or did I not?
Yeah, if it's a perfect pipeline with no issues, this is fine.
This is fine, right? So actually this is fun, right? So that's what I keep saying. Data structures is not the only subject that is fun, right? This is much more fun because you can do whatever you want.
Like, what is the point in keeping my clock also here?
Yeah, you can
We are
keep
just
the
counting number of instructions. We already know that number of instructions.
Excellent. Okay, excellent. So somebody said, what is the value? What is the use of doing this? Yeah, can you tell
Branch
me what?
instructions.
Huh?
Branch instructions.
Yeah. So what will you do if you have a branch instruction? Will you decrement the counter or will you increment the counter more?
You increment it, assuming you have 1 stall for a branch.
Yeah. So somebody is saying we'll increment. So, but he will say the answer that I can actually look at the assembly instructions, look at how many branch instructions are there. First, I will add 1 clock cycle for every instruction. And then if there are branch instruction, if there are 10 branch instruction, I'll add 10 more extra and tell you that is the IPC. So why should I do all this?
So we can't say that if we have 10 branch instruction, then they will run only 10 times. Like there
Yes.
can be a loop.
There can be a loop, right? Okay. Any answer for that argument? So do you want to simulate, or you can analytically say by looking at the assembly instructions that this is the IPC that I will get? So the question is, can you build an analytical model before simulating? I mean, I don't want to simulate. I just build an analytical
If
model.
we already know the values, then we might think to try something like this.
Values of what?
Values of the initial registers and the memory segment.
Do you
all
think
those
that you will
things.
be able to set the IPC because without simulating? Let's say you know the value of R1 and R2, but you don't know the value of R3, but R3 is dependent on R1 plus R2. So you have to do R1 plus R2, right? Which means that you have to simulate what the ALU is doing. What is the ALU doing?
Yes,
ALU
sir.
is doing R1 plus R2. So can you do it without simulating? Like, can I figure out what is the value of R3 before I adding R1 plus R2?
No, sir.
Okay. Any other questions? Okay. So we'll leave it here. I mean, this is not the answer. Of course, there are many more challenges because you will have stalls and you will have to figure out what to do with the clock. And I mean, I don't even know whether this is the right answer, whether I have to put my clock here or put it in instruction fetch or maybe put it everywhere else. I don't know. I just wrote because this came to my mind now. So you will have to figure out that out, right? So you have to figure out, okay, does it make sense to put it here? And if you put it here, then let's say there is a branch instruction. what do I do next? Which means that I have to, let's say you encountered something like this, right? Let's say you encountered, let's say you encountered a branch, a backward branch, right? Which means that same piece of code executes multiple times. Then what will you do with the clock? Wait. So will I just consider this as new instruction and go ahead with it?
Yes, sir.
Yeah, you can do that. But can you do some optimization? Maybe. And let's say you come up with a stall, then what will you do? Yeah, you have to think about all these things. Okay. Okay. Are there any questions, or we'll move to the next topic?
So for the forwarding part, we have to implement only those two forwarding from that memory execution state to IDRF and
Yeah, that's fine. Yes. Yeah, so one thing I would say is don't look at the code before you design it in your head. Spend time designing, thinking about how will you build this design. And don't look at your seniors code, or because they might have done, I'm telling you, right? So some of the batches approached it the wrong way. They implemented using timers, they implemented using multi-threading in Python, multi-threading in C++. So you'll just be copying the mistakes from here to there, right? It's not that they got, I mean, of course, even if there was evaluation, of course, they didn't have evaluation because of the COVID, but if they had evaluation, I would have given them full marks, because I'm more interested in the thought process, and the thought process was perfectly right. But there is a better way to do it. So you will have, I mean, don't just look at those code and just copy those ideas. Like you might say, I have not copied, I have come up with my own implementation. That might be true. You might have converted the Python code to C++ code, but that is not what I'm looking for. I'm looking for an idea which is yours, which means that you have thought through this design end to end. So don't Google for the thought process, because once you know this thought process, implementing it is just while loops, and this will not take much time. So try to figure it out. Take it as a data structure challenge, because that is much more interesting for you if it is interesting. Take it as a challenge and try to implement this. So that's what I would say.
Sir, what will be your judging criteria? Like, will you look at the code and like how good we have written the software or something like that, or will you think from the hardware perspective?
No, I will ask you the design question. So I will ask you, why did you take such a design choice, and what made you to come up with such a design choice? Let's say somebody said this, right? While loop my clock plus plus, I'll keep it in instruction fetch. Then I'll ask you, why did you keep it in instruction fetch? So you should have an answer to why did you choose to do it there, and that answer need not be a right answer. You should be convinced that that is the right answer, and you should convince me that that is the right answer. Yeah, by now you would have already known that my evaluation criteria is different. It's not the same question paper that you generally look into, right? So I am more interested in the thought process. So I am more interested in what is the design criteria that you chose, and why did you do it this way? I'm more interested about the why and not how. You might know multi-threading, you might implement it multi-threading. That is for a different course altogether. Or if you have some insights into, say, okay, you thought that this optimization will work, and I want to implement this optimization, and maybe this did not work. But this was the thought process that I came up with this optimization. I will be more than happy to discuss with that, such an optimization. Okay. So there are two more things for today's class. The other thing is the announcement regarding the project. I don't know how many of you remember. Okay, so evaluation pattern I just answered, right? Yeah, somebody's asked for evaluation protocol. So that's what I said. So we will evaluate it by running the code and also discussing with you. Like I will call you for a Zoom call, and then I will discuss with you, and I figure out what do you know about the project. So that's why I said, irrespective of how good your partner is, it does not matter, because finally you will be talking to me one-on-one, and I will discuss with you. It will not be on even an interview. I will discuss, and I will ask you for your design thought process, and then you will be evaluated on it. But that's one part of the evaluation. The other part of the evaluation, I think I mentioned it before. Your other team will, some other team from your class will be evaluating it. And how does it work? Let's say there are 24 teams. each team will be paired with an opponent team, and the opponent team will take your code, evaluate it, right? And you will evaluate their code, and you will write a one-page document of saying what is good in their design and what is bad in their design, and if it fails, why it fails, if it works, why it works. So let's say, I don't know, let's say Amit Bhai and somebody else is a team, and Aditya is one more team. Now, if they are opponents, Aditya's team will take Amit Bhai's code, run it, of course, with their help. You can discuss with them, but you will run it and you will note down the points of what you think is good in their design and what you think doesn't work in their design. And why do you do it? Because more often than not in industry, you will not be starting, let's say you join Facebook or Google, whatever it is, right? You will not start writing code on your own, which means that you will not design Facebook from scratch, right? Like let's say Facebook took you and you will not design the front page from on your own, or you will not write the entire Facebook on your own. You will be working on some module in some part of the industry, right? So here the idea is that you will understand how to read others' code and see, okay, this is their thought process. But if I had were in their position, maybe I would have done this, or maybe there's something to learn from their design. Maybe I will incorporate it in this design, something like this. So you should, the ability, it's not just the ability to write good code. It's also, I mean, it will help you in industry if you are good at reading others' code and finding bugs or finding design patterns and either incorporating them or critiquing them or whatever it is, right? So this is an important thing which you might have done in software engineering, but I want you to do it here because you might think about it. Of course, for phase one, it might not make much sense, but you'll still do it. But for phase two, it will make much more sense because for phase two, you will be looking at it from their lens and you will be looking at it there from their design perspective. So you might come up with something. So you saw the design I came up with, right? So maybe when I was writing this design, some of you might be thinking, okay, this guy is writing very bad design. Maybe if I were in his position, I would have done this design. So that will give you some insight into somebody's design. So that's the one of, so, and that marks will also, like, so you will evaluate on a scale of 10, how much marks will you give it for your opponent? If everybody gives 10, then it's up to you. But I would say be honest and try to evaluate it. Of course, finally, I will be the judge of how much marks finally you'll get. So it's not like somebody will rig you. Somebody will bypass this system. Finally, you'll be discussing with me. But that will be a good exercise for you to figure out and understand others' code and think about it from their perspective. So don't take it as a Herculean task. It's an enjoyable thing, right? Like reading somebody's code and figuring out and critiquing them. So that's one component of the evaluation for all the phases. So Monday, I will put up the list. It will be chosen randomly. So each team will have an opponent team and you can exchange codes. You can do it offline. You don't have to do it through me. You can call them, discuss with them. If there's some bug that is not running, that piece of code is not running, you can write that you found this piece of code, this bug, and then you can write, this is what is there, this is what is there. Yeah.
So on Monday, like.
No, you don't have to submit on Monday. I'll submit that Monday. I will tell you the instructions for doing it, and you will be given like 2 weeks time to do that.
For the evaluating thing.
Yes.
So we'll be evaluating phase one.
Yeah, you will be evaluating phase one. Yes.
Okay. So also today's lab is about the project, right? So when do we submit that? Can we have like a few days because
so few
we
days
are supposed to I don't know, maybe till the end of the weekend, Monday.
But
because we're supposed to discuss the project, right?
Yeah, discuss can happen anytime.
Yeah, so if you discuss today, tomorrow.
Okay. Yeah. Okay. So Sunday night you can submit.
Yeah. Okay.
Yeah, but the reason I'm giving it as a lab is because I'm giving it so much importance. Phase two is the most important. See, phase two is the thinking barrier, right? So once you shift that thinking barrier to thinking about clocks as not the real world clock, but something that you are designing, then the third phase will be very easy. I mean, it will just be child's play, right? Because you would have gone through that learning curve of understanding that the clock is not the real clock, but a logical clock. And this is not new. I mean, even distributed systems has it in a different way. So when I teach distributed systems, I tell them that there is no actual clock, but we have our own clock, a distributed system clock, which is much more challenging because there's no one single clock because there are multiple systems that are running together. And I am asking them to simulate something. Okay. Are there any other questions, or I take 5 more minutes or 10 more minutes? But are there any other questions?
So you said that it discussed those instruction count, those pin tool, and those things.
Yeah, today I don't think I'll have time. I'll postpone it to next lab or sometime.
Okay.
Yeah, can you remind me? Can you remind me either as an SMS or somewhere? Just you can reach me before 1 day before the lab
Okay.
on Wednesday. Yes. Sorry about it. I mean, there's too much things that are going on that I'm totally losing track.
Sir, for lab 6, like for each group, one submission is required, or
Yeah, one submission is fine. Yes, but submit the same thing, same document. You ask your friend also to submit the same document, so that for evaluation it will be easy.
okay, sir.
Yeah, but it can be copied. I mean, it just be copy paste.
So what does question 2 mean? Like we don't have to submit anything for that.
You
right?
don't have to submit anything, but I hope that you will go and
Okay.
read the document.
Go and read. Yeah. Okay.
Yeah, question 2. I mean, it's not a question. I would want you to go and read. Simple Scalar was one of the early simulators using which lot of real, very good research papers were built. And then, of course, now it's multi-core era. There are other simulators, but Simple Scalar was the golden standard simulator for simulating any research idea that you had. People published a lot of papers on it from 1990s to almost 2010 or 2012. Today, the simulator is called Gem5, which is very famous. But, yeah, if something is not working, then you can, when you submit, you can just put it as a comment. That is perfectly fine. If you're phase 2, you're not able to do it. Okay. One more thing is, if you're not able to do phase 2, let's say you are stuck with challenges, you will still get full marks. I can guarantee you that you will still get full marks as long as you are able to identify why that is not working. So as I'm just repeating it again and again, I am not worried about your end output. Yes, it's good to have an output, but the more important thing is you gave it an attempt and you had some original ideas and you tried this. So as long as you are able to write it in a document saying that, okay, sir, I tried this way of implementation for phase 2, but I was stuck in this function. I was stuck here. I was stuck here. This did not work. If you discuss with me, you will get full marks. So it is not like you should do it and I will only come as a robot. I will just execute the instructions. If it comes entire output, then I will give you full marks, or else I'll give you 0. No, I will not do that. I am not a robot, right? So it's not an automated evaluation that I'm doing here. So I'm more, so if somebody send me a private message, this is not working. Yes, it's fine. If it's not working, it's perfectly fine. As long as you're able to figure out, or even if you are not able to figure out, if you are able to tell me why is that the approach that you took, you are entitled for full marks. Okay. Yeah, don't worry about the end output. See, here you are like my colleagues, right? So you are already here in your second year. You are no longer kids. It's not like second PU. You are writing JEE exam, and there's an OMR sheet which the software will evaluate you. Here you are here to learn, which means that you can learn only if you make mistakes. Yeah, you can. Yes. Yeah, the only way to learn is by making mistakes. If you don't make mistakes, how will you learn? Okay. So are there any other questions? Okay. So I thought I will have time to discuss the midsem question paper, but I think I'm running out of time. So I'll just discuss one question. The other question I will discuss in the next lab or sometime. One of the questions that I asked is about, will you discuss with the compiler team? Will you discuss with the workload analysis team? Will you discuss with these people, and so on and so forth? Most of you have written good answers. But if somebody wants to discuss that answer, yeah, please go ahead. Like, what do you think you would do, right? So do you think that a company will work where the compiler team will be in touch with the architecture team, the workload, and what do you mean by workload analysis team and things like that?
It would be nice if we had all those people to work with.
Yeah, why do you think so?
I mean, if we know what are the instructions that we are going to execute, we can optimize according to that only.
Yeah, but if you optimize it according to that, then will not the general process, I mean, the idea of having a general, let's say you bought an Intel chip and they said that, no, we have not optimized it for your instructions, so it will run slow for you. Will you be happy with it?
No, won't be having.
Not really.
If you're designing a general processor, then your workload analysis guy will give you appropriate information, right?
Yeah, what is the information that he'll give you?
Um,
What
I
kind
don't
of
know.
instructions?
Yeah,
What
he
is the
was.
percentage of each type of instruction, like load
No,
word or
no, okay, but what program? No, no, the question what she's or what somebody is asking is what is the program that you will choose? Okay, the workload analysis guy has to tell you that this is the percentage of branch instructions. Let's say the workload analysis time guy will say this is the percentage of branch instructions. But what is the percentage of branch instructions for what program? Is it for WinZip or is it for some media player? Or
So for whatever is the user generally uses this for, like whatever
yeah,
audience you're targeting, the workload guy will obviously study
let's
from that.
say Devesh, you are now the CTO of Intel, and you have to sell these chips, and you also have to tell the workload analysis guy. So what is the programs that you will pick for the workload analysis team to analyze these programs? Will you like your audience now, right? Like say you are in Intel, you know who is your audience. Everybody is your audience.
Yeah, you have a general anybody.
General, anybody
Yeah,
is their
yeah.
audience, right? So then what program will you pick?
So you said there'd be like standard
that's
benchmark programs, right?
spec programs you were said.
Yeah, okay, I think I have told this. So there is a
Yeah,
consortium called SPEC.
spec exactly.
Yeah, so they have a set of workloads for multi-core, single-core, multi-threaded, a lot of variations. Uh, they would choose a set of say 30, 40 benchmarks with different inputs. So generally it comes up to like you can have any combination of it. So generally the combinations space can just explode. So they would choose like a zip a compression algorithm, a media player, a TCP/IP network protocol, anything and everything that you can think of as a general user might use. So they come up with a set of benchmarks and they say that this is the benchmarks. Now, for a company, it not only makes sense if you analyze the workloads and optimize your processor for the set of workloads. So then you will be worried about what is the average branch instructions in this entire suite of workloads. It cannot be one answer, right? Because though it's called an average, it's not cannot be one answer because it has so many programs in together. One program might not have any branch instruction. The other program, 90% it might be branch instructions. So it will be just a spectrum of this. So they'll not just be taking an average, but they will be trying to optimize it by using something called k-means plus string and things like this, but we'll not get into it. But the idea is now you have a set of workloads and you are building your next architecture such that there is one common platform to evaluate whether your architecture is performing well or not. So let's say now, not IIT Tirupati because we don't procure so many systems. Let's say Infosys. Right. So Infosys has hired 10,000 employees and they want to procure 10,000 systems. And they go to Intel and say, "We give me 10,000 systems." Intel will say, "This is the best processor, and you can buy these 10,000 systems." And then they will go to AMD and say, "This is the 10,000. I mean, I want to buy these processors, 10,000 processors." AMD will say, "This is the best processor that is available." Now you will ask, what is actually the definition of best? Is best does it mean that best means only that the processor which has higher frequency, or the processor which has lower power consumption, or the processor which has more cache? The answer is not straightforward. So generally, these companies, what they do is they ask for the spec score, and the spec score is not just one number. Of course, it's a number, but there are multiple numbers. So one is with respect to power, one is with respect to heat dissipation, one is with respect to performance. So they will take these numbers, and since it's a common platform, they will go and ask Intel, "What is your spec score? What is your?" And they'll go and ask AMD, "What is your spec score?" They will get these suits of benchmarks, and they will figure out, okay, this is my specs, this is spec score, and this is the cost that they're asking for. Then Infosys will do a cost analysis, like they're saying, if I go from this spec score to the higher spec score, is the cost that they're asking, is it worthwhile? Then they will make this purchase. So it works both ways for the person who is purchasing and the person who is selling. So to sell, you should have a good spec score, and to buy, you are looking for a good spec score. Of course, it need not be spec; it can be any other benchmark. These days, there are many other benchmarks. You can just search for this very good website called anandtech.com. They keep doing a lot of processor analysis, memory analysis, GPU analysis, and things like that. You can read about them. The way they analyze a processor, they just don't say this is the frequency. Like it's not like Deepika Padukone coming on the screen and saying, "I have an octa-core machine with this much amount of memory. You should buy this processor." No, it's a well broken down analysis of a processor. So they will actually tell you how they analyze the processor. They will have different scores, and it's an interesting read exercise. If you're interested, you can just say anandtech.com. Of course, not of other websites too, but this is a very old website. You can just do anandtech.com, i7 processor or AMD ROM processor. You'll see how they have actually analyzed this, what each benchmark means. So when the processor is in the processor company, when you're designing it, there is an entire set of team whose whole goal is to just do workload analysis. And you might think that what they are doing is just running some benchmarks and figuring it out. It's not that simple. It's a very complex task. They run it for, they have to choose what is the best benchmark to run, because they cannot run each and every benchmark, each and every combination of the benchmark. They have to figure out what is the hotspot of that particular benchmark. If I'm running a compression algorithm, what is the hotspot? Which part of the code is taking huge amount of time? And then they give some insights to the people who are designing here. They will think, can I give some analysis such that it will help the people who are designing some system? And they will have idea about the previous generation processor. They will, the workload analysis will say they are working for, say, Intel. They will have a rough idea about how i5 was designed, i3 was designed, or i7 was designed. And they will say, okay, this is where we are lagging. Maybe they would have run their benchmarks on this. And this is what they have, the simulators for the next generation. They will run all this. They will give you of course, these meetings will keep going back and forth. And then the architecture people will actually start designing. And when I say architecture people will start designing, they will design the way you are designing a simulator. They will have their own in-house simulator. They will design the simulator and say, okay, this is the architecture that I'm freezing. And then they will talk with the compiler team also to say, what are the optimizations that you guys are giving us? Can you add this optimization if you are bringing your own custom, if you're releasing your own custom compiler, maybe LLVM compiler, maybe some optimization to G++ compiler, or whatever it is, right? And this will keep going back and forth. And then the architecture team will hand over the architecture to the actual designers, which means that they will be writing the VHDL in Verilog code. And then it will actually go to people who are actually converting this VHDL code to circuit. And then it goes to fabrication. And then after so before the fabrication, there will be testing of this chip, not the chip, but there's something called verification phase for an electronic circuit. And then it will be fabricated. And then there will be testers. So this entire duration is around 3 to 5 years. And once the chip is out, the architecture team is again involved. The reason is you have the chip, you run it, and you see whether my simulator predicted the same amount as the actual chip is giving, right? So that's an interesting question to ask. I have a simulator. I had built a simulator for this particular chip. And I had predicted that if I run this benchmark, it will take 10,000 cycles. But maybe the chip, when it got fabricated or when the design came out, it is taking 10,200 cycles. Now, why is it taking 200 cycles? Because I have built the perfect simulator. So then you come and fix the bugs in the simulator, because that simulator will be used to predict for the next generation of processors. So this is a feedback loop that will make your in-house simulator more robust as it goes ahead. So this entire process is a very interesting thing. Yeah. Okay, anyway, I think I can go on like this. So yeah, do this Lab 6 seriously. Think about it. Don't copy. If you are not able to do it, it's fine. But you should have an answer of why you are not able to. It should not be that I was lazy or I was sleeping. It should be some technical answer. Okay, so we'll meet you on Monday, I guess. Yes, Monday. And hopefully I start a new topic by Monday. I was hoping today, but
So we don't have a class tomorrow.
yeah. Sorry, one more thing. Yeah, tomorrow there is no class because I'm driving back to Tirupati. I was in my hometown. Actually, I've been on leave from past 1 month. So tomorrow my leave gets over. So tomorrow I'm driving back to Tirupati, so I will not be able to take a class.